Okay, folks, so we're looking at the last two library functions. This one is a critical one, the inverse function. How does this function work? It's worth seeing why we give it the name. Sometimes it's called the reciprocal function. So if we take f of x, let's just take, for example, f of 2, and we plug it into this function, it spits out the reciprocal of 2. Similarly, we could take f of 1/2, and that would spit out the reciprocal of 1/2. So 1 divided by 1/2, but that's equal to 2. So for every number, it spits out its multiplicative inverse. Well, let's be careful. Not quite for every number, because one number doesn't have a multiplicative inverse. What is it? F of 0 is undefined, since 0 has no reciprocal. That's important because then the domain is from -infinity to 0, unioned with 0 to infinity, or you could have written that also in set builder notation. And that'll have implications for the range as well. So I'm going to do this one backwards. I do want you to have this basic shape memorized, but because this is one that sometimes students are less familiar with, I want to actually do a little bit of point plotting here. The reciprocal of 1 is itself. It'd be 1 divided by 1, which is just 1. And so we've got the ordered pair 1, 1 on the graph. We've also said that when we plug in 2, it outputs 1/2. You can actually see I've made little 1/2 tick marks here. My eyes aren't very good, but maybe you can see that, the little 1/2 tick marks. So if we plug in 1/2, it spits out 2. And if we were to plug in, say, 4, it's going to spit out 1/4. And if we plug in 1/4, it will spit out 4. So that's a way we could actually carefully plot a few points to try to ascertain the graph of this function. And if we did the same thing with the negative numbers, well, it turns out the reciprocal of -1 is -1. Again, if you did f of -1, that's equal to 1 over -1, which is just -1. So -1 is its own reciprocal. The reciprocal of 1/2 is -2, and the reciprocal of -2 is -1/2. And if you plotted some more points, we would find that this is the shape of that reciprocal function. Okay. This is the first function that we've drawn of our library functions that has what's called vertical and horizontal asymptotes. So this graph has a vertical asymptote right here at x equals 0. In calculus, we'll be able to give a better explanation why we have a vertical asymptote here at x equals 0, but at least let's say that we can all agree that 0 is not in the domain because 0 has no reciprocal. And what we saw was as we plugged in numbers getting close to 0 from the right, we got out very large output values. If you plug in, say, 1 over 10, you're going to get 10 out. And so that is what gives that sort of asymptotic behavior. Likewise, this graph has a horizontal asymptote at y equals 0, because no number's reciprocal is 0. And you could do a similar argument for explaining that horizontal asymptote, but those arguments are best left for calculus class. So looking over here, I do want you to be able to quickly sketch the graph of your inverse function or reciprocal function. And the graph of that reciprocal function looks like this. Notice that we've got this vertical asymptote here at x equals 0. You should draw the asymptote, even though it's not part of the graph. You should still draw that dashed line to represent it and label it as x equals 0, and do the same for y equals 0. So again, you do want to have this function's graph memorized. Okay. The range of our reciprocal function is -infinity to 0, union from 0 to infinity. This function is decreasing everywhere it's defined. So on -infinity to 0, unioned with 0 to infinity. Always, as we go to the right, the function is decreasing. And it's never increasing. And what else do I want to say about this? I do want to say that f is an odd function. And that f has no maximums or minimums. Okay. Lots of other things we could say about that graph, but there are a few facts. So again, folks, this is the graph of this 1 over x. It's the first of the library functions that introduces this idea of asymptotes, which I know that we've seen in some of our trig functions perhaps, but this is the first of the library functions that has an asymptote to it. The last function here is the step function, or the greatest integer function. It actually has many names. So sometimes it's called the step function. I like to call it the round down function. Now, careful here. You know how to round numbers, but this specifically tells us to always round down to the lowest integer. So this one, again, just like before I show you the rough sketch of it, let's actually plot some points on this. So to do that, I'm going to go ahead and take, say, the number 1.1 and plug it into this greatest integer function. And so what you do with this function is, I call it the round down function, because you round the number 1.1 down to the nearest integer. Okay? But it has to be rounded down. That's the key word, and I know that you don't always round numbers down. So let's do another one. So for example, if I did f of 1.9, I don't say to round this function, I say to round it down to the greatest integer, and so that would be 1 as well. But if I were to take f of 2, if you were to round down 2 to the great, it's already at an integer, so that's 2. F of 2.1 is 2. F of 2.4 is 2. And f of 2.7 is 2. And there are many other values between 2 and 3 that get rounded down to 2. So interestingly enough, if we were to go plot some points on here, for example, when we plugged in 1.1, we got out 1. And we plugged in 1.9, we got out 1. And when we plugged in 2, we got out 2. And when we plugged in 2.1, we got out 2. And when we plugged in 2.4 and 2.7, we have all of these points here. But notice there's going to be an open dot here, because if I plug in 3, the graph is going to immediately jump up to the number 3. And so sometimes this graph is called the step function, and you can see that by the shape of its graph. Now, it works the same way with the negative numbers. You just have to be a little bit careful when you round down negative numbers. So for example, if I were to take f of negative 1.1 and I round that down, that gets rounded down to negative 2. And if I were to take f of negative 1.9 and I round it down, it gets rounded down to negative 2. So we actually have that same behavior over here that we saw in the right-hand side. I kind of wish I had made this axis a little bit smaller, but we'll fill in what we were given. So that's our step function, also called our round down function. So here's the shape of it. This is a good function to practice with. I will say in my pre-calculus course, I won't be doing a whole lot with this function. But what's kind of nice about it is we can say a few things. So for example, the domain is all real numbers. I can round down any number I want, but the range is only the integers. Set of y values such that y is an integer. Okay. This graph is constant on intervals of the form n to n plus 1 for n an integer. That refers to that step part. For any values between 1 and 2, the graph is constant. For any values between 2 and 3, the graph is constant. For any values between 3 and 4, the graph is constant. But we don't include the integers in that answer for it being constant. And what else do we want to say? I'm going to go ahead and just say, I'm not sure what I want to go here, so we'll just go ahead and leave this blank. Okay, So folks, we have here our library of functions. I will say that this 8th one, it's worth seeing. It's not one we're going to deal with a whole lot in our pre-calculus course, but the remaining 7 functions here you'll want to have memorized. The identity function, the x squared function, the x cubed function, the square root function, the cube root function, the absolute value function, and the inverse function, the 1 over x function. So all of these graphs you want to have memorized. When I say that you need to know them, you need to be able to do 2 things. One is you need to be able to give what I've called the rough sketch without plotting any points or just a minimal number of points. And then if you wanted to draw a careful sketch by plugging in points, you could do that as well. I want you to develop both of those skills. All right, folks, that's all I've got for you in this pre-work. Thanks for your patience. We'll see you next time.